Okay, so we're now on Module 2, Topic 3. And we were dealing with Once Upon a Graph. We're on page 189. So, we're going to look at the sequence of numbers. 4, try that again. The term numbers, the first term, the second term, the third term, the fourth term. The first term is 4, the second one is 6, then 8 and 10. So now we're going to write these as an ordered pair. So ordered pair, 1, 4, 2, 6, 3, 8, and 4, 10. And then we're going to graph it. So 1, 4, 2, 6, 3, 8, and 4, 10. And there you have it. Okay, so the next thing we're going to do is you're supposed to cut out the graphs at the end of the lesson and then sort them. And so I know I have to go all the way to the end here. So here are some graphs. Oops, wrong graphs. There they are. So we would look at these graphs, and then we would look at these graphs. And you're supposed to decide what groupings you would want them in. Now, some people do like, oh, this one's a line, and this one's a line, and I know you guys, you say straight line. Oh, this could be a line if I connected the dots. This could be a straight line. This could be a straight line. So you could do it like that, and then all the rest of them not be straight lines. Oops, I didn't mean to do that. I meant to. We could also do, I don't know. Let's see. This one will touch the y-axis. This one will. This one, this one, this one, this one. Oh, all of those do. That one will not touch the y-axis. Neither will D. C will, E will. A doesn't, and B doesn't. We could do it like that. So there are several different ways that you could do this or put them into groupings. You just need to explain what you did and why you put them the way you did. Okay, so on this one, a discrete graph is a graph of isolated points. So it just wants points. Like that. Continuous is when it may not be an actual line, but it's connected. The points are connected. They have connection to them. Okay, I am so erasing that because that looks ridiculous. Okay, now what it wants you to do, are there any graphs of sequences discrete or continuous? Okay, are the graphs of sequences discrete or continuous? So if I looked at our warm-up, because this is a sequence right here, is that discrete or is that continuous? Is it connected or is it not connected? So they are not connected, so they would be discrete. The points are not connected. Okay, so what you're supposed to do right now is you're supposed to go down here, go down to those graphs that we were just looking at, and decide if they're discrete or continuous. So I'm going to come down here because that's just how the mop flops. That's how the cookie crumbles. So I want you to look over them. Are they discrete? Are they not discrete? Well, this one's discrete. This is continuous, 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 discrete. Oops, then I can get rid of this ridiculousness. There you go. So this is continuous, 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 discrete, continuous, continuous. Okay, awesome. So then the next, I know I need these pictures much closer. Okay, so we're gonna sort sort the graphs into four groups that are increasing, those that are decreasing, those that both increase and decrease, and those who are neither increasing or decreasing. Okay, so we're going to look over here. When you're determining when a graph is increasing or decreasing, you analyze the graph from left to right. Okay, so is the graph going up? That would be increasing. Is the graph going down? That would be decreasing. If it goes up and then down, it would be both of them. If it goes straight across, it would be neither. Okay? So here we go. We're going to look. I know. Sorry about this. So now let's look at this. If I'm going from left to right, these points, they go in this direction. So this would be increasing. If I looked at B, again, it's going up, so this would be increasing. This one, look at it. If I'm going left to right, ignore, I'm going to use black. Ignore the arrows on this, okay? So if I'm going from left to right, this is going downhill from left to right, and then this is going uphill. So this is both increasing and decreasing. This one, it's increasing, it's decreasing here, but increasing here. It's increasing here, but decreasing here. So that's both of them also. So increasing, decreasing. That's both of them. So if I look here, and again, ignore the arrows. If I'm going from left to right, this is going downhill. So that means that this is decreasing. Oops, I forgot the E. This one, left to right, it's not doing anything left to right. It's not going up or down. It's just there. So this is neither. I know that N is weird. Okay, let's look at this next ones. Okay, again, this one, letter G's, it's not going up at all. It's staying constant. So this is neither. Okay, this one goes up, then it goes down, then it goes up, then it goes down. So this is increasing, decreasing. Now this one, as I'm going from left to right, it goes decreasing here, but increasing here at the same time. So again, this is increasing, decreasing. Look at this one. It's got points everywhere. So again, this is a neither one. This one, look, it even shows it. This would be decreasing. And then look at this one. It increases, it stays the same, and then it decreases. So this is increasing, decreasing. Okay, so let's go back. I know, hopefully I won't have to do this too many more times. Sorry about that. Okay, a linear graph is a graph that is a line or a series of collinear points. What does that mean? Points that lie in the same straight line. So we're looking at this one right here. if I was to connect the points, if I was to connect those like so, they would all of a sudden be linear. It would make a line. So it's called collinear when they would make a line. Sorry, this is being silly. Nonlinear graph is a graph that is not a line, therefore not a series of collinear points. So if I look back, I know, one more time back down here. So the letter A, that would make a line, so this would be linear. This one makes a line, so that would be linear. This one, that does not make a line. That makes a parabola, so this is nonlinear. This one definitely doesn't make a line, so this is again nonlinear. This one also doesn't make a line, so this would be non-linear. I should have done all of this in different colors. And then this one, it would make a line, guys. It's okay if it's a vertical line. It still could make a line. Then next one, this one. Okay, it's horizontal, but it's still a line, so it's still linear. Then this one, it's never going to make a straight line. So this is called nonlinear. Then this one, again, not going to make a line, nonlinear. This one, whew, not going on here either, nonlinear. No way that that's going to make a line. And remember, a line has a constant rate of change. Okay, this one has a constant rate of change. So this one is linear. I know, it looks like an E. This one has several different lines, but it's not just one straight line. It's not one constant rate of change. And so this would be nonlinear. Now, if we were just talking about like this part right here, that part right there is linear, but when you add on the rest of it, it would make it nonlinear. Okay. Maybe that's the last time I go down there. Let's see. Okay, so now we're going to interpret this. A lot of times people look at these graphs and they're like, oh, they're going uphill. It doesn't necessarily mean that they're going uphill. Let's look at this. It says distance. So how far you walk or how far you run or whatever. But this one has to do with from home. Okay? So right here at this point right here at the origin, that's home. So it's talking about how far Greg is away from his home. And then this is how many hours it's been. So I'm going to change the color a little bit. So this one right here, this part right here. So he went away from home for 2 hours. For 2 hours, he drove away from home 120 miles. Okay? So he went away from home for 120 miles. Then right here, that's a half an hour. So for a half an hour, he was still 120 miles away from home. So that means he could have been, you know, having dinner somewhere, or I don't know, maybe traffic stopped, you know, coming home from Vegas. That happens a lot to people. Whatever, he's stationary. He hasn't moved away from home for a half an hour. Somebody's going to say, how did you know it was a half an hour? If you look here, guys, these are going up by halves. That's how I knew. Okay, so then this says that he's going away from home again. So when we start at 2.5 hours right here, he's 120 miles away from home. And when we get to 4.5 hours, he's now 180 miles away from home. Okay? Then he stays still again for an hour. So maybe he's having another lunch break or dinner break. And for an hour, he stays where he is. Now, he's going to go back towards home. Okay, he's going back towards home. So from 5.5 hours to 8 hours, he's going home. He's going back towards his house. Then all of a sudden he stays still again. I don't know why he's staying still. Maybe he went to his grandma's house and stopped there for an hour and a half. How'd I know it was an hour and a half? It goes over 3 times. Each one is a half an hour. And then last but certainly not least, he's going back home towards his home. Not going to make it all the way home. But for a half hour, he's going closer to home, and he would be at 100 miles away from home. Okay, so I'm glad I talked about that. Now, let's answer these questions. It says, how far away from home was Greg after driving for 2 hours? So here's our 2 hours. How far away from home was he? He was 120 miles from home. How fast did Greg drive during this time? So that's miles per hour, isn't it? So in order to do that, I need to do slope. So we started at 0, 0, and then we got to 2, 120. Now hopefully you remember this is proportional because it goes through 0, 0. So all you have to do is 120 divided by 2, and you'll get that he was going 60 miles per hour. Then it says, how do you know that Greg traveled at the same rate for the first 2 hours? Well, isn't that a straight line? Isn't that a constant rate? It shows that it's a constant rate because if it wasn't a constant rate, it would go up and around and do something like that because you're slowing down. There is a constant rate of change. There is a constant rate of change. Now it's looking for between 2 and 2.5 hours. Okay, so that's what we were talking about. This is 2 and this is 2, this is 2.5. So how far away was he from home? I didn't mean to undo that. Sorry about that. Okay, he continued to stay at 120 miles from home. So he's still 120 miles from home. How fast did he travel? He stayed still. It's a horizontal line. What's the slope of a horizontal line? 0. So 0 miles per hour. Describe the shape of the graph. A horizontal line. And by the way, it's a line segment. It's not actually a line, but that's okay. And that doesn't need a period because that's not even a question. Okay, so we're going to label this section of the graph with letters A through G, beginning from left to right. And then we're going to record the table, or the information in the table for the time travel. Okay, so we're going to go back up to this graph. I'm going to use a different color so it's maybe not that color. Maybe I'll use purple. So this is A, this little part was B, C, D, E, F, and G. How do I know that? Because look right here. It says A is from 0 to 2, B is from 2 to 2.5. So this next section is going to be 2.52, so let's see. Area C went from 2.5, ooh, that was horrible, to, why do I do that? It's going from 2.5 to 4.5. Okay, so I'm going to come here, 4.5. And then the next section is going from that 4.5 to 5.5. So 4.5 to 5.5. Then it's going from 5.5 to 8. So 5.5 to 8. Then from 8 to 9.5. And then 9.5 to 10. Okay, so Greg traveled 120 miles from home at a rate of 60 miles per hour. So that means I need to find the slope on each one of these. Okay, so let's come back up here and let's find the slope. I'm not going to go back and forth on this, so hopefully you can see what I'm doing. We've already found the slope for A and B. We're going to find the slope for C. So let's draw this little triangle right here. Oops. If I draw that triangle, let's see. We're starting, I'm going to get rid of all that. We're starting at 120. Okay, and we're going up to 180. So how tall is that? Well, that is 180 minus 120. That's 60 tall. Then down here, we're going over a half an hour, a whole hour, a half an hour, a whole hour. So that's 2. So the slope on that is 60 over 2. 60 over 2. So that's going to get us 30 miles per hour. Notice how it's not as steep as the other one? Okay. Let's see. I'm not going to write Greg all the time. Greg went another 60 miles at 30 miles per hour for, that was weird, 2 hours. Okay, and then we're going to do 4.5 to 5.5. Hopefully you noticed that it's a horizontal line. So now we're at 180 miles away from home. Okay, so Greg took a break at 180 miles from home. Then we're going back towards the house, boys and girls. We're going back towards the house. So that we have a negative slope going on here. I'm going to pick a different color. Let's see, I don't know. Go with brown. Okay, and then here. Okay, so again, we're going over a half, a whole, a half, a whole, a half. So 2.5 hours. We're going from 180 to 130. So that would be 50 tall. So that means my slope, oops, I didn't mean to do that. My slope on this one is 50 divided by 2.5. Now, some people have a hard time doing what I'm doing. All I did was multiply the top and the bottom by 10. So that would be 20. Okay, so his rate is 20 miles per hour. Greg is traveling back towards his home at 20 miles per hour and stops at 150 miles from home. Okay? And then 8 to 9.5. Isn't he staying still? At F, he just stood still, didn't he? Okay, so at 150 miles, oh, it's not 150 miles, it's 130 miles. Sorry about that, guys. 130 miles. So at 130 miles from home, he stopped to take an hour and a half break. Oh, I forgot. Okay. And then last but not least, he's still going back towards the house now. He's still going to go back towards the house, so we're going to use, I don't know, yellow or orange. Okay, so we're going to draw this right here. So this down here is a half an hour. And this, he's at 100 to 130, so that's 30 tall. So if I'm going to find the slope of this, 30 divided by 1/2. Remember, we can't divide by a half. We have to multiply by the reciprocal. And that would be 60 miles per hour. So Greg traveled back towards home at a rate of 60 miles per hour until he was 100 miles from home for half hour. Oops, hour. There you go. Awesome. So on this next part, it says the crew of a community pool is prepared the pool for opening day. The graph shows the depth of the water in the swimming pool after X hours. So at 0 hours, it was 7 feet. Then it decreased to 5 at 6 hours. And then there's none in it at 8 hours. It sits there for a while. And at 14 hours, they start filling it back up. So oh no, we're not going to do that. Okay, we're going to name the intervals again. A, B, C, D, E. How'd I know? Because I read ahead. Why do you think it was emptied and refilled? Need fresh water. Maybe there was a leak. Maybe, I don't know. For some reason they needed to empty it. So now, our time intervals. So this time interval, the first one is 0 to 2 hours. And then 2 to 6 hours. And then 6 hours to 8 hours. And then 8 hours to 14 hours. And then 14 to 20. Okay, then you need to find the slope of each one. So I'm going to change colors and we're going to find the slope. So that's 0. That was easy. the slope of this one, of this line right here. So let's draw this. So 5 to 7, that's 2. From 2 to 6, that's 4. So the slope on this is -1/2, because 2 over 4 is 1/2. And then we have this one. This is 2, that's easy. And this is 5. So the slope on this part is 5 over 2, or 2.5. This one down at D, hopefully you can tell the slope is 0. And then this one, okay, so it goes from 14 to 20, so that's 6 across, and this goes from 0 all the way over to 9. So the slope on this is going to be 9 over 6, which is 3 over 2, which is 1.5. Okay. For 2 hours, the level stays the same. Then at 2 hours, it starts to drain at 1 foot per 2 hours. And then from 6 to 8, at 6 hours, it drains at 5 feet per 2 hours. Or you could also say, you could have also said at 2.5 feet per hour. Oops, I meant right. Oh, really? Per hour. And then it stays empty for 6 hours. And then last but not least, it fills back up at a rate of 3 over 2. 3 feet per 2 hours. But isn't it better to say 1.5 feet per hour? It makes so much more sense. Was the pool being emptied at the same rate of the time? No. No. Because it started off emptying at a half a foot per hour to 2.5 feet per hour. So it changed. Why does it make sense for the graph of the situation to be continuous rather than discrete? Because it's not like it stops and starts, stops and starts, stops and starts. It's not like all of a sudden you take a whole bunch out all at one time. It actually has to drain. Okay. So students of East High School are designing ceramic drinking cups for the art project. The students chose a variety of different shapes for their cups. 6 of these shapes are shown. Okay. Would you want Ryan's? If it's a cup, I think you would be draining stuff out. Sorry. Okay, so let's look at this. It says to test the cups, hot water is poured into each at a constant rate. The graph shows represent the height of the liquid in each cup as the volume changes. Okay. Now, I'm going to start with this one right here. As you pour the water in, it doesn't have any volume. Isn't that the one I was just talking about? Because if you pour something in, doesn't it just drain right out? So I think this one would be Ryan. I'm pretty sure. Okay. So this next one, B. So it fills up really quick and then it's really slow. So it starts up really quick and then is going really slow. So I'm thinking it would be Blake, wouldn't it? Because when you have a smaller amount of volume right here, that would fill up really quick and then like really slowly fill here. So I'm going to go with Blake here. And then this one, C. Oh, I don't know. Maybe I want to take that one off of Blake. Maybe I want to take that off of Blake because look at this one. This one is super quick and then almost stays the same. This is super quick and then gets even quicker. Super quick, slows down, and then super quick. Okay. Well, let's look at Nico. Wouldn't Nico feel really slow until you get to the tippy top? He would be like slow at the tippy top and then fill up quick. So I'm gonna say that I'm gonna go with Nico. One of these two. I'm gonna go with Nico on one of those two. I have to look to compare. So this would do slow, or it would go fast and then it would get slow and then it would get super fast. So this is one. Timothy is one that at the end fills quick. So the end fills really quick. Oh, this one right here, this has a fast constant. Look at how steep that is. So that one is definitely Timothy. Let's look at, okay, so I got Timothy, I got Ryan. Now Monica would be slow. Okay, hers would go up slow, then fast, then slow. Slow, fast, then slow. Oh, I think this one's Monica. And then, okay, so I've got that one. This one is super fast, or it goes up fast and then kind of peters out. Ooh, Jacqueline. I think this one is Jacqueline. Ooh, I don't know. This one looks like it could be Jacqueline also. Okay. fast, super steep. Nope, I am going to go with this one still being Blake. I like that one still for Blake. That one Jacqueline, and then this one Nico. Okay, hope you enjoyed.